Okay, so I think we should start discussing. So who would like to go first? Yeah, Pandu,
Point
go ahead.
um, regarding nozzle reinforcements
Yeah.
and the maximum forces and moments in a tank nozzle, how to determine these things, Abhishek?
Uh, okay. So what I have
How I
understood.
can say that this no like the piping vendors sometimes they are asking what is your terminal load limits like that they are asking. So for
Mhm.
which I am unable to define them the loads.
Yeah. So you're asking how to decide what is the maximum allowable nozzle loads,
Correct.
right, for my vessel,
Yes. Yes.
isn't it? So see now, first of all, you have to understand from where these loads are coming. Why we have nozzle loads? Then what is
Because
the
of the
reason?
connecting piping, no, like they
Correct.
have flange connection from our
Mm-hmm.
tank nozzle. Because
Correct.
of that connection, we are experiencing nozzle force.
So because of that connection, whether all the time you will have that loading. See, if you are just worried about that connection, like if we are doing some connection and if it is properly supported with bellow in the pipeline, then you will not face any loading due to the additional piping attached to that vessel or the nozzle. Do you agree with that? Pandian, are you able to get what I'm trying to explain?
Terminal point. Before the terminal point, if pipe is supported, there won't be any forces. Correct. This is what you're saying.
Yeah. So I'm saying, see, there you're saying, for if let us see I have a vessel, okay, and there
Okay.
is, I hope you guys can see my screen, that
Yes.
whiteboard. Yeah.
Yes,
Yeah.
Abhishek. You can.
Yeah. So see, this is a vessel, okay, and there is a nozzle attached to this vessel, and we know that if the nozzle is provided, it has to be connected with a pipe, right? So there will be flange of this nozzle, and then there will be flange of pipe. Okay. Then pipe will be connected like this. Okay. Now, why these loads are coming? Because of piping. If I support this pipe, okay, first of all, you have to understand why this is coming. So, like, there is a weight of this pipe, right, which is hanged by this nozzle. The nozzle is supporting the full weight of the pipe, isn't it? So, it will transfer the load. Also, there will be thermal expansion of this pipe. Whenever the temperature in operating condition, if the temperature is increasing, your thermal expansion will be there of that pipe. Okay. Because it's very long, so the expansion will be more crucial for piping rather than your nozzle and vessel. Okay. So that will also depend upon the length of that pipe. Like if the length is very large, the expansion will be very high, and so the load also will be very high. Are you guys getting it? Yeah.
Yeah. Yes. Go
Yeah.
ahead, please. Yeah. I can understand.
Great. So now if I support this pipe, which is coming and getting connected to that nozzle, if I support here, then that weight effect is not be transmitted to the nozzle. Okay. But what about thermal expansion? Thermal expansion still will be there. So if I provide a bellow in the pipe, okay, so that will be able to take care of all the thermal expansion. Okay. So again, that thermal expansion will not be transferred. So what I'm trying to say is that nozzle load, which is coming on the nozzles, actually depends upon the piping configuration, how it is connected, whether there is support is located at what distance, what is the thermal expansion value. Okay. Because of this, your nozzle experiences nozzle loading. Clear? Now, if I have to find out what is the maximum allowable nozzle load, what is the normal sequence is piping will do the stress analysis based on where they have provided the location, okay, and what is the thermal expansion value, and they will give us the nozzle load. Okay, that is the actual procedure which should happen.
Here it happened in a reverse way, Abhishek.
Yeah,
Yeah.
I'm coming to that, why it happens like that. Okay, because see, if you are in very start of that project, see, piping stress analysis is done at very last when all your piping configuration, piping layout is finalized, right? All the elevations and everything is fine. So at the last stage, they will be doing stress analysis.
Exactly, this is what happened. Yeah.
Yeah, and that to that time, if if you wait till that time to finalize your vessel, it will be too late to fabricate it, isn't it? Because pipe fabrication is not going to take time. Your vessel fabrication is going to take time. So we cannot wait up to that time that they will do the stress analysis and then they will give the load and we will design the nozzle loading for that. So what happens then? We have to give a value of what maximum load we are going to consider for this nozzle, okay, which my nozzle will be able to take. So we'll consider some value, we'll design the nozzle for that, and then we'll give that value to piping. So whenever they are doing the stress analysis, they will keep in mind that this is the load for which nozzle is designed, and they'll try to restrict the nozzle loads which is getting transferred to your nozzle. They'll restrict that load which is getting transferred to the vessel nozzle. Making sense? Yeah.
Yes, yes, Abhishek.
Yeah. So
The picture which you written is drawn, no, is the ideal condition. This should be
yeah,
the actual thing, but it didn't happen in that way. So what happened is they are looking for terminal forces. Again, as you said clearly, like they want to restrict their terminal forces below that limit. Yeah.
correct. So that's what I'm saying. So in other case, when we have to give the nozzle loading, we either follow some general standard, which is for, you will get EIL standard or even client specification, which will mention some loading, which maximum you can
allowable.
consider, and you can design your nozzle for that load. Okay, so we will do the WRC calculation considering that load. Okay, we'll put all the values, we'll run the WRC calculation PV line, and then we'll consider we have designed for that load, and that load will be given to the piping department so that they can restrict their nozzle loadings within that limit. Making sense?
Yeah.
Yep.
Yeah. So you will have to take some standard values, and you can do by trial and error also in PV Lite, putting the maximum value, which if you feel that there can be some like thermal expansion load can be governing in that case, you can put that value more. Okay, but that doing trial and iteration is very difficult. Okay, so normally we follow some standard like EIL standard, or if any client specification is there, then definitely that will be the guiding point.
Okay. So as you said, no, Abhishek, like trial and error. So FX, FAFG, which force I have to give more? The other two components, how in what ratio I should give input?
Yeah. So
Again,
there is
that's
no.
a combination number, no? Like that's what I'm lagging there. Yeah.
Yeah. See, I'll just share my screen. I can open PV Lite and I'll tell you what we can do. Yeah, so like if I have a vessel and I have a nozzle attached, okay. So let us take 6-inch with pad. The vessel thickness is less. So first of all, we'll have to qualify that vessel.
I am seeing only one screen, that sketch. Are you running, sir, Pavlite?
Yeah, you are not able to see that PV Lite?
No, sir.
We are seeing your that sketch one, tank and nozzle sketch.
Okay. Close. Now,
Yep.
Yeah.
now you can see, right?
Yes,
Yes.
sir.
Yeah, great. So I've just modeled one vessel. I thought you guys are able to see it. No problem. Just I've added one cylinder and I was adding that nozzle. I'll just keep that nozzle elevation so that we can, cylinder length is 3000. So I'll take 1500. Okay. Now I have added that nozzle. Okay. If I have to do WRC calculation, I'll go in this. Now, which WRC to be performed? 107 or 297?
So 297.
297. Are you getting it, Pandian? Why 297? Why not?
No, Abhishek, honestly, no.
Yeah, I think you will be, not gone to that section till now.
No, not yet. Yeah.
Yeah, and so we have covered that WRC and 297, but basically 297 gives the stresses in both the nozzle also and the shell also.
Okay.
Okay, 107 will give you only stresses in shell. It will not give you the stresses in nozzle. There are lots of parameters, but I'm just telling you one why we are selecting here 297. The main reason is we'll get stresses in both because we have to qualify nozzle as well as shell. Okay, we cannot just qualify shell and say that we have calculated the stresses. So 297 is what you have to select for cylinder to cylinder. The limitation for 297 is it is only applicable for cylinder to cylinder. If there is a mother shape, you cannot apply that. Okay, but here we have cylinder to cylinder, so we can definitely apply. Now, if you go see here, there's lots of standards available. Okay, like that you can, if you have some specification which you are following, you can inbuilt in PULite itself, and if you just select that, the loadings will be already taken from that. Making sense? If you don't have any specification and you want to just randomly put some values, so due to thermal expansion, which force will be more prominent? If the piping which is attached, again you see thermal expansion may be a problematic for you. So which force here in all these forces and moments, which one will govern more for thermal? Any idea?
It
So
should be
radial
P.
force. The radial force.
Yeah, radial force P. Okay, because see, mostly the thermal expansion will be always linear. Okay, so it is going to affect your radial force. So if you feel that the radial expansion is going to be governing, okay, but before the project is finalized, that is also difficult to predict. Okay, only basis you can say that if the temperature is very high, you can imagine that that because of this temperature, your thermal or linear expansion may be more. So considering that, you can evaluate. But finally, the length of that pipe, that is going to be the governing criteria for this force. If there is a bend in pipe, okay, immediate bend in pipe just after nozzle connection, then also the force goes down. Okay, because the bend will be able to take care of that thermal expansion. That is the reason always, if you see, whenever that vessel is connected with a pipe, immediately after they will provide some bend. Okay, so that way you control the thermal expansion. Making sense?
Yes, Abhishek, you are correct.
Yeah. So now you can put all the values which you want here and randomly, and then try for which value it is failing, which value. If you can see the effect of all of the loadings also. So 5,000 will be very less load for this. So I'll just take 50,000. See, now if I say 50,000, your vessel at pad edge, that is failing. Okay. Can you imagine which location it is? Vessel at pad edge.
Sir, I have one question, sir.
RF pad location, it means, correct? Vessel at pad is means.
Vessel at pad edge means?
RF pad location.
So whether the stress is in RF pad or shell?
RF pad extreme end to cell, that junction.
See, if there is a pad here, okay.
Yep.
So finally, that WRC gives the stresses in shell or nozzle. So this is the stress which is getting generated here, at least this location where that pad is ending.
Yeah, correct.
Correct.
That's what I meant.
So the stress, yeah. So that is correct. So it is stress at now. If you have to, reduce this stress, what can you do? If you don't have that option to reduce this load, but you want to minimize this, is there anything you can do?
We increase our bad thickness.
Sorry,
We increase thickness.
increase the.
Thickness.
Yeah, he's saying increase the RF pad thickness.
So whether increasing the RF pad thickness will help? See, that stress is not in RF pad. It is in
Shell only.
shell. So
So
if
increase in cell thickness.
Shell in thickness.
shell thickness will definitely help, but you'll not like to do that because that will be too much cost implication for that.
Nozzle thickness.
Okay,
whether will
So,
have-
RF pad diameter.
Sir,
Sorry?
stiffness.
Increase RF pad diameter.
One by one. Adnan, you are saying something?
We increase RF pad diameter.
Yes, that's very correct. So see, finally, what is happening? Why this load is the stress is governing? That might be reason that see finally there is a lower area which is taking care of this radial load. So one thing is we can increase the diameter, okay, of this pad. Okay, that will work only when you have within the limit of your reinforcement. Beyond that, not have much effect. So let us increase that. Definitely, we may not completely eliminate it, but some advantage we may be able to get. See, from 1.7, it is down to 1.4. Okay. Now, if I
Sir, how these stresses are coming because of the pad?
how the stresses are coming because of pad means?
How this is related to pad dimensions?
See, because pad is also providing stiffening, right? That thickness till that location is more.
Okay, sir.
Where your pad is providing that stability to that load. That factor is also considered in WRC.
Okay, so the WRC considering pad dimension as
Pad
well as
dimension also.
shell dimension.
Yeah, because we finally that if some moment is getting created due to that load, that it will be affecting at the pad OD. The shell stresses will be more where your pad is, till what your pad diameter is there. Now let us see if I increase the thickness. Let us see if any implication is there. So from 8 mm, let us make it 16 mm. We are increasing more so that we can see some visible, values change if anything is happening. Okay. So now if I have increased the T, even if I change that to double, no change in the stresses. Okay. Now let us see, I increase that OD further, make it 200. Now it is 1. Okay. If I make it 250, see, by increasing that pad diameter, I have controlled that stress at OD.
So if we provide the stiffener gussets,
See, gusset you can provide, but that calculation you have to do that in FEA because that
Okay.
configuration cannot be considered by WRC.
okay.
See, WRC just take care of this diameter factor because that is affecting your opening size. Okay. So,
yeah, Abhishek, that is a point like still gussets. In which condition they are providing those gussets?
yeah.
Once we are unable.
Yeah. We can discuss that also. So now the next question is that for which nozzles you provide gussets, right? That is what you are asking. Pandian, Is that rightly? I'm
Yes.
asking the question. Yeah.
Yes, Abhishek, you are correct.
Yeah. Correct. So you might have seen that gussets only for smaller size nozzles, normally for 2-inch or very rarely for 3-inch. Mainly for 2-inch, you'll see gussets, or we call it as stiffeners attached to that nozzle. What do you think may be the reason for that? Why
You
for
said nozzle section very less to withstand the bending. It's a cantilever condition, no?
correct? So what happens? See, when your nozzle size is small, so your schedule, even increase in schedule, your thickness will be very small compared to when you have larger diameter. Okay, and when you have smaller size, smaller thickness, your section is weaker. So if something is hitting your nozzle, okay, maybe during transportation or installation, it may immediately break. Okay, it will be very weak. So just to strengthen that smaller nozzles, 2-inch, which are very fragile, we provide stiffeners. Okay, 90-degree apart, 2 stiffeners. That is the standard. So if you want to avoid this, many times client will say that it does not look good. Okay, when you provide stiffeners, it is not suiting that appearance of that vessel. So what you do to avoid stiffener, if you don't have to provide, then what you will do? You go for long well neck nozzles. So long well nozzles are LWNRF, you might have heard of, right? Have you heard of that?
No,
Long
Abhishek.
well, not heard of. So
No,
for
not yet.
2-inch or 3-inch, we select LWNRF nozzles. So that is like that nozzles comes with flange attached to it. Okay, and the thickness is more because that is made from forging. So you have larger thickness and your flange is already attached to it. You don't have to do any welding. I'll just show you a picture of it so that you can visualize. So these are long weld neck. So your neck will be larger and it will be thicker. So they are more stronger than your normal 2-inch pipe. So we prefer that if we have to avoid stiffeners for the nozzle. Making sense, Pandian?
Yes, Abhishek. Yeah.
Yeah. So only for 2-inch nozzles, for your specific question, that when we provide stiffener, mainly for 2-inch, very rarely for 3-inch. If you have very smaller thickness and you feel that it may be very fragile, for that you can provide. Otherwise, you only for 2-inch nozzles, you provide always stiffeners. If you want to avoid that, you have to go for long weld neck. If you're selecting long weld neck, you don't have to provide stiffeners.
First, we shall go for with the stiffener because the long one will be costly.
Yes, that is the part. So unless client will demand, fabricator will not provide that because they cannot accept any cost increase. Okay. So if client is insisting, then you are bound to do that.
Actually, I saw this gussets in a different scenario. It's like lateral kind of inclined agitators where the drive is mounted on the nozzle.
Correct.
So
See,
there they have provided this one.
that is completely different scenario, Pandian.
Oh,
that
okay.
reason is, see, because now if you are mounting an agitator, I'll just unshare the screen and I'll move to the.
You got the picture, no, Abhishek? What I'm saying? Yeah.
Yeah, I got it immediately.
Yeah. There I saw. Yeah, that's right.
And so, see, normally what happens, there is a vessel, okay, and we are providing a top cover, and then there is agitator mounted on that, okay, from the top, because we have to do some agitation, some reaction is happening.
It's a side entry agitator actually. Yeah.
For side also, see,
Side
can be side or top, all depends. But for top also, like if it is flat head or maybe slightly conical, that agitator provides a dynamic loading to that flat head. Okay, so whenever it is dynamic, why I'm calling it dynamic load? Because it's a rotating part. Okay, so always there will be some dynamic loading attached to it. Okay. So once dynamic comes into the picture, you have to go for FEA. So to avoid that, what we do, we consider a equivalent static load for that. For that dynamic load, we calculate equivalent static load. That is by thumb rule or by good engineering practice, you can say we consider twice than what dynamic load is there. Okay. Otherwise, you may definitely ask the input from the client itself, because as a pressure vessel vendor, you will not be making that agitator. They will outsource from some agitator vendor. So he will be able to give you the dynamic loading. Okay. So you can consider equivalent static load. And then with that static load, see, because you have to now your top plate has to sustain all this loading of agitator. Okay. And you know that for top plate, thickness is always critical. Okay. Even smaller pressure,
So
we have to provide very large thickness.
screen is not in center, sir. Actually, we are not seeing.
Not in center means you're not able to see it?
Yeah, completely, sir. It's going to.
For all of you?
Oh, I'm seeing your sketch window.
The sketch is not in center, sir. Actually, is it something?
No, Uday,
set-
what you can do now, you can change in setting. You go
okay,
to
okay,
view.
sir. Okay, sir. Now it's okay.
Yeah, so you go to view and you can change your settings, because based on your settings also it changes.
Okay, sir. It's okay.
Yeah. So anyone if is facing that problem, you go to view and just make it speaker view. So you'll be able to see whether in standard or speaker view. Okay, I hope you all can see that screen.
Yes.
So now if this is the load, for that case, you may have to provide stiffener for first of all supporting that top plate, because increased thickness again may be costly affair. So you can weld some angles or C channel on the top plate to support that agitator. Plus vertically also you can provide some stiffeners. So that becomes completely different scenario. Then you have to optimize like Rourke, you have to follow Rourke book, because you will not get these calculation from PV Light. And there is no standard formula. So from Rourke, you can design that special flathead with that load coming on the center. Okay, getting it, guys? Same thing happens for when if the agitator is coming from the side. Okay, that also, see, because agitator is a moving part. So you need to provide stiffening to that nozzle. If the nozzle is, resting your agitator, then it is always because of dynamic loading, your nozzle is going to fail. So you have to provide additional stiffening to that nozzle. Making sense, guys?
Good morning.
Keep yourself muted, guys. Yeah. So I hope it's clear now.
Yeah, Mr. Abhishek, now because of the have dynamic load, so we have to go to find the element, right? Because of fatigue stress, right? Or
Fatigue.
other-
See, fatigue is again a different thing. If it may not happen, that fatigue may happen because of this load. The variation may be very small. So it's not compulsory that you have to go for fatigue in this case.
Oh, okay.
Okay. See, for fatigue also we'll just take one class actually for fatigue. It's not first ASME section 8 division 1, but at least you guys should know how fatigue affects our design and which case we should try to design for fatigue. So I'll take one full lecture on fatigue, because that is going to take time. So we'll from the start we'll build on the concept first, and then we'll discuss only about fatigue in that class. Is it good, Adnan?
Yeah, thank you, Mr. Abhishek. Thanks a lot.
Yeah, welcome. So we'll take fatigue in a separate class, and we'll keep on discussing like this fatigue, any issue like creep or anything is if it is bothering you and you are able to, it is there in your project, we can discuss that. Okay. See, creep and fatigue, how we do the calculation? We have to go for FEA. So it comes under section 8 division 2. Okay, the qualification. So definitely it's not part of this course, but at least basic things we should be able to understand. Okay, so that will be the purpose of that class. Okay, guys.
Okay, Abhishek.
Okay.
FEA means in which tool you are?
It's we can use ANSYS, or there are lots of other tools also available, but ANSYS is
Okay.
the most prominent FEA tool which is used.
Do you have any sample? Abhishek, like
Sample
report of
for?
the analysis, FEA analysis for the particular nozzle?
Yeah, we have done lots of FEA
Oh,
analysis for nozzle. So if you want, we can share, but I'll have to eliminate lots of things. So I'll have to modify it for you, because those are all
okay.
confidential data for client. So we cannot directly share, but at least I can share some parts. So if we go to our website also, it's good to add. You'll get uh, we have provided blog in that, and that is related to fatigue. We have made a very nice blog. So if you guys want, I can share in the group also. Let me just quickly do that, because we may forget later on, so that you guys can go through that blog. You will be able to understand lots of things. Still some issues there, definitely we'll discuss that. Okay, so I'm just copied that and I'll just post it in the group.
Abhishek, sorry, I am for interrupt. If you have nozzle, as you know that intersection nozzle perpendicular to the vessel only will be under WRC 297. But if you have degree, if you have a degree or coming not perpendicular to the shell, it also will
Correct.
go under division 2.
Yeah, then you cannot use 297, because 297 is clearly for cylinder to cylinder and perpendicular intersection. If it is
Yeah,
inclined, then you have to go for FEA.
and will be division 2 also, right? For criteria
Criteria?
of checking the nozzle will be also division 2.
Yeah. So see, criteria will be definitely division 2, because your stresses, finally, if you are doing FEA, you have to calculate the stresses and give the qualification of those stresses. Like that, you have to categorize the stresses, whether it is primary stress, whether it is secondary stress, or peak stresses. Based on that, your allowable load differs. If it is primary stress, it is limited to allowable. If it is peak, you can go up to 3 times of the allowable. Okay, so when we do FEA for these things, we have to do the classification of load first, and then once the classification is done, you can compare it with allowable. So that will be always in division 2, because division 1 does not talk about other types of load. It is only concerned about primary stresses.
Thank you, Mr. Abhishek. Thanks a lot.
Thank you, Adnan.
So, which means Abhishek, the horizontally inclined nozzle also it won't be applicable for WRC 297 checks. Then
No,
it's a vertically inclined. What you drawn, this is not applicable.
see, if this is my vessel, it may be
Okay.
horizontal or vertical. So the nozzle is
Okay.
vertical in this case. It is horizontal in this case. Okay.
Yeah,
My
horizontal in the
nozzle,
sense I am saying tangential connection. Yeah, some nozzles are in tangential
yeah,
connection.
tangential connection will not be applicable. Only it is for perpendicular. Okay, like if I got it, what you're trying to say, let us see if I can. Okay, see, like if I have if we see this cylinder in this view, okay, and my nozzle is like this. Okay, in this case also, we cannot do with WRC 297. WRC 297 is completely with your perpendicular connections like this. Cylinder to cylinder and perpendicular.
So for shell stresses we can perform, but 107.
107 you can do for calculating, but then for client you
No.
have to give the stresses in nozzle also. Client will ask that.
Yes, sir.
Right? So that is the problem we face when we do the calculation for your descents. Okay. So whenever we do for descents, so descent is what? Like if let us consider there is a torus spherical descent. Okay. And there is a nozzle attached to that torus spherical descent at the center. Can I use WRC 297 for this case?
No.
Descent is not spherical, no? So cylindrical, so you cannot.
So this descent is torus spherical. Okay. And this nozzle is cylindrical. So can I use that? Just think a little bit about it. Can we use WRC 297?
I think it's no. Abhishek, like both should be cylinder is the condition, no?
Yes, that is the condition.
But torus spherical means a different profile, correct? So you cannot use it.
So what is exactly this profile is at this location? It is actually part of a sphere. Yes, it is
107.
part of sphere. Because see, finally at this location there is a uniform radius, but that is sphere, and this is completely for cylinder to cylinder. Okay, so it is not for sphere to cylinder. So we can use only 107 for that. So once client will always require the stresses in both the cases. So you have to perform whether nozzle pro or FEA for that nozzle which is coming on the descent. Okay. Making sense?
Okay.
Mr. Abhishek, I
Yes.
have one more question. Sometimes I facing in my job nozzle with lip type. There is no RF bad. There is a lip type. They have a connection with the shell. Will be the nozzle itself have like lip consider like a RF bad. When can you use this one?
I could not understand. Can you just repeat?
Okay. Sometimes I'm facing in my job long neck nozzle
Okay.
with lip type.
Correct.
Instead of RF bad, they are using lip
Okay.
like extension. So when can you use this one?
Yeah, I'll tell you now with starting. Okay. See now what happens whenever nozzle we are connecting with a shell. Okay. Now let us draw a shell. Okay. I have to connect a nozzle. Now how I can connect? See, one thing is that I can just make a hole there. Okay. Insert my nozzle if it is set in, or if it is set on, then just keep my nozzle at the outermost position and then weld it with fillet weld. Okay. That is the first approach. If it is set in, we will take it up to the inside. Okay. Make a groove where we have cut that hole for that nozzle and then weld that groove. Okay. That is the second approach. Now in first and second, can I do radiography of these welds?
No.
No, you cannot do. No,
We cannot do
only
radiography because it's
only
a corner joint, right? So
yes.
now see reinforcement and the radiography or strength requirements are little different. Okay. If only the reinforcement is problem, so for reinforcement, what I can do, I can either provide a pad. I can provide a pad. See, because reinforcement is nothing but just compensating that area which you have lost, right? And that compensation you can do in both the direction. In this direction, I can put the material anywhere within this diameter, and there is limit on the thickness side also, normal to that cylinder. In this location also I can put material which will be contributing to your reinforcement. Is it making sense till now, guys? Is it making sense?
Sir, are you drawing something like
Yeah,
we are saying
you cannot see it.
we are seeing only the white sketches, the white screen that sketches are there.
I'm drawing. You cannot see that what I'm drawing.
Yes,
Abhishek, I
okay.
can see, but the last point, what the reinforcements you are trying, no, that alone I am unable to differentiate.
What I'll do,
Maybe-
just a minute, I'll close this blackboard. I think that is creating some confusion. Just wait. And I'll share my screen and let us draw it in AutoCAD. That will be, you know,
Yes, sir, that will be better actually.
I can draw it also properly. You guys can see clearly. Now you can see AutoCAD opening.
Yes, yes.
Yeah. Now it not be a problem of, you know, so because the whiteboard is built in Zoom, so it's difficult to, and now what we are following is just sharing that screen, so it will be easier for us. Okay. So what I'm talking about, like if I have a shell, okay, I have drawn one shell outer portion. I'll just draw the thickness also so that we can understand it better way. Okay. Now this is the shell cross section. Okay. Now I have to attach a nozzle. So I can attach like this. I'll make a hole here. Okay. So I have made a hole here and I'm attaching my nozzle. So if you want, I can give the thickness to that nozzle also. Okay. This is my nozzle. Okay. So this is set-in nozzle, right? If I have a set-on, I'll keep this at the OD of the shell. I hope all of you understand what is set-in and set-on, right? If any confusion is there, let me know. I'll explain that also. Guys,
Yeah, Abhishek, go ahead.
set-in and set-on is clear to everyone, right?
Yep.
Great. So this is set-in nozzle. So if I have to weld this nozzle to shell, what we do, we create a hole for that set-in. We provide a weld edge preparation to that shell. We call it as WEP. And then okay, we will weld here. Right? This is the weld. This is how we follow, right? Now,
Correct.
right? So see, one part is that strength of this joint. So if you focus just on that, okay, then what I can do for this weld maximum, if I have to, qualify this weld, that whether it has been done correctly or not, whether there are any faults in that, how can I determine that?
A strength point of view.
Yeah, strength of, see, for weld, what we do non-destructive examination, right?
Okay.
So which kind of non-destructive examination will give us a strength equivalent to base material? Which kind of radiography will give me assurance that this weld is as good as base material? What is that non-destructive examination?
UT, sir.
UT, sir.
Only UT?
LPT will give is performed, but it is give only the surface cracks.
Yes. And what about RT?
RT cannot be performed here.
Yeah, in this case, we'll talk about that. But my question is that if I have to qualify any weld, so what we generally do, we do RT, right? And based on RT,
Yes, sir.
see, based on UT, there is no joint efficiency, right? Our joint efficiencies depend upon RT. UT is kind of alternate for RT, which you can follow. So there are two different methods and two different, based on two different physics basics. So see, now for this weld, can I do RT?
No, sir.
Okay. If someone is asking that question, which I have asked, like, can we do? So the answer should be yes, we can do, because RT is what? RT is just a source and film at the other side, right? Doing RT is not a problem. RT can be done.
Results are problem, sir.
But it is called meaningful radiography. Means whether we are able to interpret the result or not. It will give me film, okay? But to interpret the film, okay, to see that whether cracks are there or not, that is also a study, right? The radiography people are qualified based on that, whether they can interpret the film, isn't it? So their qualification is based on that. So it's not like it's not red and white. Like if you might have seen LP, liquid penetration examination. Have you guys seen it? How we do LP?
So I'm daily seeing it.
Okay. What about
Yes, sir.
others? See, if you have not seen, just Google it. Okay. You just see in YouTube, you will see clear video. So that is what exactly it will be done. So when you do LP, there is very clear cut yes and no, right? Uday?
Yes, sir. Yes, sir.
Yeah, because if we do dye penetration, if you know what we do, we provide some liquid which is very penetrating, and then we'll spray with white. So if it is some cracks are there, the liquid will go inside, and you will see a clear cut pink line wherever the cracks are there. So it's yes or no kind of thing. But radiography and ultrasonic are not like that. You have to interpret it. Okay, it's a film. Based on the color of the film, you will see that which kind of defect it might be. So there are also debates, when we study film. One inspector may say that it is this defect, another may say no, this is not, this is something else. That also may happen. So it's not clear black and white kind of thing. Is it making sense? So for this kind of wells, it is really difficult to evaluate the results. So doing meaningful radiography is not possible. So when I say not possible, see, in science, nothing is like not possible. So what even this kind of things also can be qualified for radiography. You know that? If it is mandatory due to some reason and you cannot do other things, even this kind of radiography you can do, and to some extent you can make it meaningful. Okay, that you can do by welding similar 10 jobs, which will be kind of what it's called, qualification jobs. 10 jobs, you do radiography, relate all the films, okay, and then you do the real job and try to compare. Okay, so in the qualification, you may also purposefully do some make some faults in that weld, and you will see that how it is appearing in the qualification. And then, but that is very cumbersome job, it will take too much time and money. Okay, so normally it is not done, but I'm saying nothing is impossible, everything can be done. But in normal scenario, we can always say that meaningful radiography is really difficult for this case. Okay, so what to do if that is not done? And if client wants this well to be radiographed, what is the other option? How we can ensure that radiography is done for this weld.
So lip type joints.
Yes, right. So I think Adnan was asking, right? So Adnan, that lip type of nozzles are really the costliest, but that is if you want RT 100% for that nozzle weld also, that is the solution. Now some of you might be wondering what is lip type. So I'll just make a lip type nozzle. Thickness will be similar to this. Just keep yourself muted. There is noise. Sorry, I'm also not that good with AutoCAD. Somehow I manage. Okay. So this is your lip type nozzle. Is it making sense, guys? So in lip type nozzle, we have lips. See, these are the extended. So these are the portion which we call lip. Okay, so it is extended. So now if I have to weld this nozzle, I'll just bring it down to that. I'll have to make opening from here. Okay. Okay. Now it will be attached here and you can provide WEP like this. Okay, and do a complete full penetration weld with radiography possible. Okay, so when your nozzle welds are getting radiographed. Adnan, is it making sense? Guys, keep muted. Adnan, you can unmute and share whether you have.
Abhishek, here the shell thickness and the nozzle lid thickness, there may be variation will be there, no? Like it cannot be a one-to-one.
Yes, but
Second
that
challenge is, yeah.
But
Tank
thickness,
versus profile, yeah.
thickness at the lip will be equal to the thickness of the shell. At the vertical position where the nozzle neck thickness is starting from here. Okay, so this may be smaller. Okay, normally how it happens, see, we have to, when it is lip type nozzle, it is made from forging. Okay, so apart from making it a lip, we also provide all the required reinforcement we inbuilt in this lip itself. Okay, so your nozzle will look like this. See, it will look like this.
There is a figure, UW16 has details for these kinds of all.
Yes. Correct. So is it making sense, guys? Adnan, this is your question. So is it clear? Is this what you wanted to ask, or I have explained something else? Adnan, you're there? Okay, I think he left. So anyone else? Have you understood what we discussed right now?
Yes, sir.
Yeah. So these are costliest nozzle and we have to select them when there is no option other than providing full welding, full penetration weld and RT joint efficiency as one. in that case, we can go with this, but this will be really costlier. And it's time taking also to procure these forgings, machine it in this shape. Okay. Because this all will be based on job. These are not standard nozzles. You have to design it first, provide the reinforcement based on all the reinforcement you have to inbuilt, because it's integrally reinforced nozzles. Okay. So you have to inbuilt in that forging, machine it accordingly, then order it. They'll supply the forging. Then you have to machine it with the shape you want. Okay, that is the step. So it takes really long time. So in nuclear, I've seen mostly we use this kind of vessels, and for also lethal substances. You may, if it is really lethal and it's very dangerous for human life, and pressure is also very high, the client may require this kind, but this is only when the client is asking. Otherwise, fabricator or designer will not provide this, because these are really costlier. So you have to justify why you did this. Instead of that, if client itself is asking, then we'll go with that. Is it making sense to all of you?